So here's the deal. Everything has an inverse. The inverse of the quadratic is a square root function. The inverse of the exponential function are logarithmic functions. And guys, all this stuff is easy. We're just, it's just new words that we're looking at. Very basic. So feel free to read through these words if you want. I am going to jump down to this table because this puts it all in math, which I understand a little better. Okay, here's what you need to remember. A log undoes an exponent. And remember, all of our exponential functions look like that. That's our basic form of the exponential function. And our variable is an exponent. So a log knocks it out of exponential form where we can actually see the answer. Do you guys know why we usually put B right here? Why is that a B? What does that stand for? Oh, it is in transformations. You're right. But like just for this, like
Base.
base. Yes, base. Also write bases never change. Okay, so a logarithmic function always equals an exponent. So guys, look. See this first example right here? That's 2 to the 4. See how it equals a 4? That's how it always is. See how the base is a 2 here? The base of this log, I know the base of the log is a 2 because the bases look like subscripts. The bases look like subscripts in log form. Over here in the middle row, the exponent's 2. Oh, look what the log equals. It always equals the exponent. I'm going to ask you that like 5 times today. Also notice the base is 2/3 here. Oh, look, the base is still a 2/3 because the bases never change. And then, of course, you have the last one. If you notice, this is a base of 10. Notice how the 10 is not written right there. I'll talk about that later on, but I'll address that. All right, so let's go ahead and take a look at our examples because this is where it all is going to kind of fit in for you. On example 1, it says to write this exponential equation in logarithmic form. What do logs always equal? Thank you very much. So I'm going to draw an equal sign and I'm going to write it's equal to the exponent of 5. What is the base? Then the base stays the same. So it looks like a subscript of a 4. By the way, notice how I wrote the word log. Y'all make sure your L's don't look like 1s. So practice drawing your L's. And then we're taking log base 4 of 1,204. The end, that's it. So look, here's how you say it. Log base 4 of 1,204 or 1,024 is 5. Like the answer to this is 5. Okay, let's look at number 2. Log base 7,343 equals 3. Now we're going to put it in exponential form. Okay, what is the base? And what do logs always equal? The exponent. So there's your exponential form. 7 to the 3rd is 343. Okay, let's see what the bottom of the page stand is going on. So truly the bottom of the page, that's like a teacher trick. Don't fall for my tricks. So listen, any number can be negative except what you're taking the log of. So this can never, ever be negative. And let me show you why. You don't have to write this down. I'll write it down. Let's say we take log 7 of negative 243, and that's going to equal, I don't know, let's say negative 7. I totally made that up. I'm going to put that back in exponential form. What is the base? 7. What do logs always equal? The exponent. Y'all, would that give you a negative number? No, it'd give you a fraction. Remember, it would give you a fraction. There's no way it can equal 243. That's going to equal a fraction. So please remember, other numbers can be negative. The answer, the exponent can certainly be negative, but never the argument. That number that we're taking the log of, that's called an argument. Okay, let's see what's on the other page. Okay, so the equality of exponents property, you guys have been doing this like for 2 or 3 weeks. You just didn't know the name of it. It's that whole thing where like, oh, you guys don't see an 8, you see 2 to the 3rd power. Or you don't see 27, you see 3 to the 3rd power. That's what this is right here. So the equality of exponents property is that right there. You've been doing that this whole time. So what we're going to do today is you guys are actually going to be solving some logs, but it's only possible when we're able to rewrite it with the same base. All right, so let's look at example 3 and example 4. What's the difference between example 3 and example 4? What does one have at the other end? An equal sign. That's right. Guys, on these logs, I always draw equal signs and I make them equal to x because it's just easier to solve. So where it says evaluate this log, I know that I'm finding the exponent. So I'm going to go ahead and write equals x because it's easier. I get through them faster. So in order for me to solve these, you got to put an exponential form. And then just do the same stuff you guys did last week. So here we go. On number 3, what do logs always equal? What do they always equal? Exponent. Right. So what is the base? It's going to be 3 to the x equals 1 to the 9. But y'all don't see it. Same. It's -2. That's the answer. What's the answer to this problem? When I evaluate log base 3 of 1/9, I get an answer of 2. And y'all, I'm really not going to write x equals 2. Like I'm not going to box in that x. I just put this here to help me solve it a little faster. That's all. So here's where we're actually solving because there is an equal sign. So let's go ahead and put this in exponential form. So the base stays the same. What is that 6 being raised to? Y'all know that. What is that? What's the answer to that? Just what it is. So on page 11, I said, oh, where it says anti-logarithm, it just means put an exponential form. That's literally all of it. So guys, I'm never going to quiz you on these definitions. Just remember, if you see that, and I've not seen that anywhere else except here, just remember it means to put it in exponential form. This stuff, we're just going to skim the surface on these 2 things. So with logs, there's like a blanket category of logs, and then there's subcategories of a common log and a natural logarithm. Y'all, the common log just has a base of 10. And the reason why we call it a common log is because of scientific notation. This is used a lot with very large numbers because large numbers have exponential growth. And since we do everything with scientific notation, if we're talking about a base of 10, we don't write it. So anytime you see a log without a base, like on a college entrance exam or something like that, y'all, base is 10. It's just understood to be base 10. And then you guys know the natural number e, it's kind of like pi, it goes on forever. We haven't done really too much with it in math. We're still not doing a lot with it in algebra 2. All you're doing is getting comfortable with this symbolism. So if you're talking about the natural number, we don't write the word log. If we don't write it like that. So we're just going to write it like that. So log base E is the same exact thing as ln. I'm done. That's all I got. Just kidding. That's all I got. I'm going to do a couple of homework problems with you because I feel like that wasn't enough. Let me just knock out a couple of problems with you guys. Okay, so back to page 11 where we started. I really want to talk to you about problems 19 through 30. Okay, good. So these are the type of problems where I would like, oh, okay. I'm just going to draw an X because it's so much easier when I know that I'm just looking for the exponent. And plus, I want to get this done real quick. I don't want to have a lot of homework. This makes it go a lot faster for me. I'm just showing you what works best for me. Okay, so I want to talk about number 23. Number 23 says log of 100. Y'all, what's the base? That's right. And guys, what do logs always equal? Yeah, so we're going to write 10 to the x equals 100. Y'all know that. What is that? Just 2. And the whole entire page should not be any more complicated than that. If you get tripped up, come talk to me because we're missing something simple. I also want to do 26. Let's do a natural log 2. Now remember that ln, that is understood to have a base of what? That's right. And all logs equal exponents. So e to the x equals e to the 2. Oh my goodness.